Believe it or not, we are entering into the very last section of our course. I know that makes you sad. I know you're going to miss me. I know you're going to miss the material. I hope that I've inspired all of you to become finance majors. Say that with a straight face. I have a straight face. Okay, now that we have that out of the way, let's go into the last section of the course, section 4 on capital budgeting. Oh, look, this collar is just killing me. Let me loosen this collar up here. I can breathe. Some of you will go into corporate jobs. You'll have to wear ties. Hopefully they'll pay you big bucks to wear ties. All right, so capital budgeting. Should we make the investment? And this is part 1. There are 3 parts to it, chapter 9. And so we'll be covering the different techniques that are out there that we will use to evaluate investment projects. Okay, investment projects. And I'm not talking about stocks and bonds. I'm talking about activities that a company should get involved in. New business activities and how to evaluate existing business activities. So capital budgeting is deciding what long-term investments should or should not be made, and examples include plant, equipment, acquiring other businesses, and developing new products. When people talk about business investment, these are the things they're talking about, not stocks and bonds. Those are investments that individuals make. All right, we'll learn how to choose between mutually exclusive projects. Mutually exclusive means you have more than one project that you're considering, but you can only do one. So if you do one, you're excluding the others. How should we prioritize our investments? Maybe we have enough money and time to do multiple projects. Which project should we do first? Which project should we do second? All right, so we should ask the following questions when we evaluate decision rules or techniques for evaluating investments. Okay, so what should these rules do? Well, does the decision rule adjust for the time value of money? Okay, important concept. Does the decision rule adjust for the risk involved with the project? And does the decision rule provide information on whether we are creating value for the firm and how much value are we creating? Our decision rules should incorporate all of these concepts to be valid decision rules. All right, so let's look at an example that we're going to use. Initial cash flow at time 0, is minus $165,000. So we are making an investment, and the cash outflow, the cost of the investment, is $165,000. At the end of year 1, we forecast that we will generate cash flow, positive cash flow of $63,120. At the end of year 2, we'll generate positive cash flow of $70,800. At the end of year 3, we'll generate positive cash flow of $91,080. Okay, so this is what our business looks like. All right, so let's jump right into our first technique, which is called the payback method or payback period. Okay, how long does it take to get the initial cost back in a nominal sense, which means we're not factoring in the time value of money? Okay, so here's how we do it. So we're going to estimate the cash flows. I've already presented those to you. Then we subtract the future cash flows from the initial cost until the initial investment has been recovered. So here's the decision rule. We will do the project if the payback period is less than some preset limit in terms of time. How long does it take for us to recover our money? And if we can recover our money within a certain period of time, then we'll go ahead and do the project. All right, assume we will accept a project if it pays back within 2 years. So let's look at this project with the cash flows that I've already laid out there for you. We'll go over the cash flows again. and let's put a time period of 2 years. We got to get paid back in 2 years. So here's how we do it. So here's our initial cash outflow. Let me get my pointer together here. So here's our initial cash outflow of $165,000. And then in the first year, we generate $63,120. So after we generate our positive cash flow after 1 year, we still have $101,880 to recover. So that will be the amount that is at the beginning of the second year, and then this is the cash flow that we generate from the second year. So we still have $31,080 to recover. Therefore, we will not recover our initial investment within 2 years, so we will excuse me, reject this project. All right, please notice this. This is how much we have left to recover, and this is how much we're going to generate. We forecast we're going to generate in the third year. And so, how do we handle this? All right, let's go through here. And so we're going to divide our remaining cash flow that we have yet to recover into the total amount of cash flow that we forecast to recover in year 3. So do that division there, and we come up with 0.34. So we think it's going to take us 2.34 years to recover our investment, and that 0.34 of a year, we'll multiply that times months, 0.34 times 12. And so we get 2 years and 4 months. Okay, so we're going to reject this project because our target is 2 years, but our payback is actually 2.34 years. Okay, simple enough. So the advantages of the payback method is it's really easy to understand the method, to understand how to do it, easy to calculate, but the disadvantages are it ignores the time value of money. Now, we could introduce the time value of money into this project, into this model, but it still misses a couple of things. So let's look at this. What if we found the present value of this, and the present value of this, and the present value of this? We could introduce the time value of money, and it would take longer than 2.34 years to recover, okay? But introducing the time value of money still does not address this arbitrary cutoff point of 2 years. How did we come up with 2 years? And very important problem with the payback method is it ignores cash flows that are beyond the cutoff date. What happens after 2 years? Okay? And so this method is biased against long-term projects that involve research and development, such as developing new products. Projects that take a long time period are going to be rejected by this method, even though they may generate a lot of cash flow and value for the firm. Okay, so we have to be careful of the payback method. And lastly, the payback method ignores the risk of cash flows. It does not incorporate, if we're looking at 2 projects, Project A and Project B, and Project A may have a shorter payback period, but it may be riskier than Project B, which has a longer payback period. So this technique does not incorporate the risk of cash flows, and then it does not tell us how much value that a project might add to our business, and that goes back to ignoring the risk, ignoring the cash flows beyond the cutoff date. Okay? So payback method is often used by companies for small projects. Okay? All right, so let's go into the net present value, our second technique, and this is considered to be the best way to evaluate an investment project. Okay? So what is the net present value? Well, net means something has been taken out. We talked about that in our review of accounting. The word net means something's been taken out. So the net present value is the difference between the value that is created by a project, well, what is that value? Positive cash flow, and the cost of the project. Okay, so the first step is to estimate the expected future cash flows. The second step is to estimate the required return for projects of this risk level. So the required return is going to factor in time and it will factor in risk, okay? And the third step is to find the present value of the cash inflows and the present value of the cash outflows. And here is our decision rule. If the net present value is positive, then we pursue the project. The net present value is measured as a dollar amount. And so if we're looking at multiple projects, we prioritize them in terms of or based on the amount of positive cash flow that they generate. So we do the larger projects first and the smaller projects second. Okay? So if a project has positive cash flow above and beyond its cost, then it adds value. All right, so here's an example. New project has the following estimated cash flows. So here's our project again. Same project cash flows that we looked at several slides ago. All right, so here are our cash flows. And the required rate of return for investments of this risk is 12%. I fixed this, and I'm not sure why this did what it did. But anyway, let's move on. So, using the cash flow keys. That aggravates me. All right, we're going to use the cash flow keys. So CF0 equals minus $165,000. Enter, down arrow. So this is a situation where we actually have a cash flow at time zero, and it is the total amount invested in the project. And let me say this up front. If a company decides to use borrowed money, you still count the entire amount of the investment, whether it's borrowed or not. So you, in order to make projects equal in terms of analysis, we always assume that all of the negative cash flow or cost of the investment, all of it happens at time zero, and we do not distinguish between equity and debt. So enter, down arrow, and then we have CO1. And here's our first cash flow, FO1 equals 1. Here's our second cash flow. Here's our third cash flow. Here's, so once we only have 3 cash flows, or actually CF0 plus 3 positive cash flows. Once we enter our last cash flow, it's time to hit NPV. I equals 12, enter, down arrow, and compute. And it gives us a net present value of $12,627.42. That is a positive number, so if this was the only project we were looking at, then we would do this project, okay? And so what I show you here is what the calculator did for us using the cash flow keys. This is how it would look if we did it using the formula. Okay, so the cash flow keys are simply doing the present value. And also notice that if NPV equaled a higher number here, if our discount rate was higher, this number would go down, it would be lower. Okay. All right, so this project is accepted because it creates value in excess of its cost, and it takes risk and the time value of money into consideration, and so we would accept this project. We would look at other projects, and if other projects had larger net present values, then we would do those other projects first. All right, so that's the end of this first section, and we'll move on and look at the internal rate of return, which is our third technique for evaluating investment projects. Peace out. Shalom.